Have you ever wondered how the universe builds everything? I mean, from a simple rock all the way up to you and me? Well, it all starts at the atomic level, and specifically with how its tiniest residents, the electrons, get organized. Today, we're going to unlock the fundamental housing rules for every electron out there.
So let's think about it like this. Imagine an atom is a multi-story house, and the electrons are all its residents. Now, they can't just pile into any room they want. That would be chaos. There's a very specific, orderly set of rules they have to follow. These rules make sure the whole house is stable and doesn't just, collapse. So what are these rules?
Okay, let's dive right in with our very first rule, and honestly, this one is the most intuitive. It's called the AUFBAU principle, and it's really all about starting from the ground floor and working your way up.
So, the official definition sounds a bit formal, but in our house analogy, it's just the lowest floor's first rule. See, electrons are kind of lazy. They want to be in the most stable, lowest energy state possible, and that means filling up the orbitals closest to the nucleus before even thinking about moving to the higher levels.
And get this, the name itself gives us a huge clue. Aufbau is actually German for building up, and that is literally what's happening here. We are building the atom one electron at a time from the ground state upwards, just like you'd construct a building from the foundation. Now, here's the key. This building process follows a very specific blueprint. Electrons always fill the 1s orbital first, then the 2s, then the 2p orbitals, and so on. Let's take carbon, for example. It's got 6 electrons. The first 2 go into the 1s orbital, the next 2 settle into the 2s, and the last 2 start filling up the 2p orbitals. It's that foundational.
All right, so we know which floors to fill first, but what happens when you've got multiple rooms, or orbitals, on the same floor, with the exact same energy? Well, that's where our second rule, HUNDS rule, comes into play. Now, I know this sounds a bit technical, but the idea behind it is super simple. Degenerate orbitals is just a fancy way of saying orbitals at the same energy level. So think of them as identical rooms on the same floor of our atomic house. HUNDS rule is basically the social etiquette for electrons moving into these rooms.
Let's break it down with an analogy. Imagine you're getting on an empty bus with a bunch of empty double seats. You wouldn't immediately go sit right next to a total stranger, right? No way! You'd grab an empty seat for yourself. Well, electrons do the exact same thing. They spread out, one to each room, before they're ever forced to pair up. It just minimizes repulsion and keeps everything nice and stable. Let's see this in action with a nitrogen atom. It has 7 electrons. The first 2 pairs fill up the 1s and 2s orbitals, no problem. But look at what happens at the 2p level. Instead of 2 electrons crowding into one orbital and leaving the others empty, those 3 2p electrons spread out, one in each of the 3 available p orbitals, all spinning in the same direction. It's the most stable arrangement possible. Okay, on to our third and final rule. And this one is an absolute, non-negotiable law of quantum mechanics. It's called the PAULI exclusion principle, and it tells us what happens when electrons are finally forced to become roommates and share an orbital.
Yeah, this isn't just a friendly suggestion. It's a cornerstone of modern physics, figured out by the brilliant Wolfgang Pauli way back in 1925. It's the reason matter is stable, the reason atoms have the structure they do. This is the rule that prevents the entire atomic house from collapsing into total chaos.
This is the heart of it, right here. Every single electron in an atom has a completely unique identity, defined by a set of 4 quantum numbers. Think of it like a unique address or a fingerprint. No 2 electrons in the same atom can have the exact same one, ever.
So these 4 numbers completely define an electron's state. The first 3, that's N, L, and M sub L, they basically pinpoint the electron's street address. They tell you its energy level, the shape of its orbital, and how it's oriented in space. The 4th number, though, the spin, can only have one of 2 values. You can just think of it as spin up or spin down. Helium is the perfect example. Both of its electrons are in the same 1s orbital. So their first 3 quantum numbers, their address, are identical. So how do they avoid being identical twins? It all comes down to their spin. One has a spin of positive 1/2, and the other has a spin of negative 1/2. That tiny difference is all it takes to satisfy the rule and let them coexist peacefully in the same room.
So we have the AUFBAU principle, HUNDS rule, and the Pauli exclusion principle. And they might seem like really abstract rules for some tiny invisible world, but together, they are the architectural blueprint for the entire universe. So why does any of this matter? Well, for starters, these 3 rules perfectly explain the entire layout of the periodic table. They're the reason matter itself is stable, the reason the atoms in your desk or in you don't just collapse into a tiny point of energy, and maybe most importantly, they are the foundation for all of chemistry. How atoms bond to form molecules is completely dictated by these simple housing rules.
So the next time you look at anything, a glass of water, the air you're breathing, your own hand, just remember the elegant, unyielding rules that are governing every single electron inside. It really leaves us with a final thought, doesn't it? What kind of bizarre universe would we live in if just one of these fundamental rules was different? The world as we know it, well, it simply wouldn't exist.